Okay, just to answer this question about the high frequency, low stakes quiz we did last time, I want to make sure everyone's good on this. So, in order to do this problem, what we need to do is we've been given a binomial expansion. We've been asked to find f of x up to and including the fourth term. Now, in order to do this, it's so interesting, write it on white paper. All right. So we need to recognize that what that actually is 2 plus x to the negative 1/2 power. And the way that we would deal with that is with this extension of the binomial theorem. So what that would turn into, let's first off just recognize what we have. So we have our a term is 2, our b term is x, and our n term is negative 1/2. Okay? So, with those things acknowledged, what we need to do is we need to write out the expansion. So, if I write out this expansion, this is going to turn to let me just go ahead and do it as 2 to the negative 1/2 power times the quantity 1 plus negative 1/2 times b, which is x, over 2, so b over a, plus negative 1/2 times negative 1/2 minus 1 over 2 factorial times b over a, which is again x over 2, and we're going to raise that to the second power. And then we're going to do, so that's 1, 2, 3 terms. We need one more term to get to our fourth term. So plus and this is going to be negative 1/2 times negative 1/2 minus 1 times negative 1/2 minus 2 all over 3 factorial times x over 2 cubed, and that would continue on forever. So that's our basic expansion. So now, in order to actually calculate this expansion, so that'd be 1 plus negative 1/2 times x over 2 would be, sorry, I shouldn't do plus, because that's in fact minus 1/4 x, because that and that gives me a negative. Okay, so negative 1 minus 1 would be negative 3/2, and negative 3/2 times negative 1/2 would be positive 3/4, but then I'm dividing by 2, so that would be positive 3/8, and then x over 2 would be times x squared over 4. And this next one, we already know that this is negative 3/2. This would be negative 5/2. So negative 1/2 times negative 3/2 is positive 3/4, times negative 5/2 would be negative 5/8, or so we've got, negative 15/8. Okay, and then we're going to divide that by, well, that's 3 times 2 times 1, so divided by 6 would be negative 15 over 6 times 8 is still 48 last time I checked. and this would be x cubed over 8. So if we've got x cubed over 8 there, so I'm just going to write this as minus 15 over 48 times 8 times x cubed. Now obviously we could reduce that further. We could make that happen. For now I'm not going to, just because that is easy enough. Now, after we've done that, we were asked, write down the interval of convergence of the completed expansion. So we're looking for the values of x that this series converges. Well, series that converge, we talked about this when we dealt with the idea of a geometric series. And the ones that converged were the ones where r, I guess the absolute value of r, was less than or equal to 1. So if that's the case, looking at the way that this sets up, we need to find the thing that is raised to a power, right? So which of these terms in our expansion consistently gets raised to a power? Well, it's the x over 2 term. So when x over 2, the absolute value of it, is less than or equal to 1, then what that means is when that happens, the series converges. So what values of x make this thing converge? Well, it's whenever x is between -2 and 2, because -2 divided by 2 would be -1, but the absolute value gives me 1. But 1 doesn't work with our convergence, right? So we're looking for the values like that. So this series converges when x is between -2 and 2, which means that instead of going off infinitely, this thing is going to lead to one value. So likely what it'll look like if we were to graph it would be something like that, where it's almost like a heartbeat, but it kind of trails off until it hits just this solid line. Okay? I really hope that's helpful, and with all my audio issues, I hope that that was viewable. Don't forget to like and subscribe. Remember, Stoltz-World rules all.